There's one last test I want to talk about for finding zeros of a polynomial, and it has to do with bounds. So these are kind of boundary points of where our zeros are located. We call a number C an upper bound if there's no real zeros that are greater than that, and C is a lower bound when there's no real zeros that are less than that number. So the rule for upper and lower bounds is we're running a number through synthetic division, just a number C. If C is positive, and each number in the last row of synthetic division is either positive or zero, then C is an upper bound. So there's not going to be any zeros that are greater than that number. If C is a negative number, and the numbers in the last row alternate positive and negative, and zero can go either way, then C is a lower bound, and there's not going to be any zeros below that number. So I'll show you what this looks like in application. So we want to find all of the real zeros of this function. So we're going to start by listing out all of the possible real zeros. We start with the factors of our constant term, so plus or minus 1 and plus or minus 2. And then remember we need to divide by the factors of our leading coefficient, which will be 1, 2, 3, and 6. So then remember everything on top gets divided by everything on bottom. So first we divide by 1, which doesn't change anything. Then we divide by 2, so we get 1/2 and 1, which we already have. And then we divide by 3, so we get 1/3 and 2/3. Then we divide by 6, so we get 1/6 and 2/6, which we already have. All right, the next thing we want to look at is the rule of signs from the other day. So we look at our function f of x, which is 6x cubed minus 4x squared plus 3x minus 2. And we want to count the number of sign changes, 1, 2, 3. So that means there are, for the number of positive real zeros, there's either 3 or there's 1. And then remember we have to look at f of negative x. So we plug in negative x, and that gives us negative 6x cubed minus 4x squared minus 3x minus 2. There are no sign changes, so the number of negative real zeros is none. There can't be any. So what that means is, remember, we listed out all of these positive real zeros, and none of them are negative. So it's either 1, 2, half, 1/3, 2/3, or 1/6. So we've eliminated half of our possibilities, which is good. So now we're going to try some. We're going to plug them in and see what happens. So let's just start with 1. It's an easy number to start with. So our coefficients are 6, -4, 3, -2. All right. So we multiply and add and multiply and add and multiply and add. Okay. Now obviously 1's not a real zero, but C was positive and the last row were all positive numbers. That means 1 is an upper bound. So 1 was not a 0, but it also means that nothing bigger than 1 is a 0. So that eliminates 2. So now let's try 1/2. We'll plug that in. So 6, -4, 3, -2. So we're going to multiply and add and multiply and add. That's 2.5, which is 5/2. And then 5/4. Sorry about that mess. Which is going to be negative something. I don't know. All right. I plugged in a positive in the last row, either positive or 0. That is not the case. So 1/2 is not an upper bound. So something bigger than 1/2 could work. Now, the only thing bigger than 1/2 that we have is 2/3. So let's try that. That's not a fantastic number to run through synthetic division, but give it a try. So we get 6. 6 times 2/3 is 4. We get 0, 0, 3, 2. That is a 0. So we did find one. So this one worked. And let's see, what else can we find? Let's try another one. Now that we know this one, I don't know, I'm going to try 1/3. So we'll run 1/3 through synthetic division. So 6, that gives us 2, -2, that gives us -2/3. That's going to give us 2 1/3. And that's going to give us, let's see, 6 7/3, 7/9. That's going to give us a negative something. I don't even know what that is. So anyway, 1/3 didn't work. And remember we said the number of possible positive real zeros is either 3 or 1. So we can't have 2 of them. So that means 1/6 is not going to work. So I'm sorry, that's a 2/3. 2/3 is the only real zero. Now, it's a degree 3, so there's possibly some complex zeros, but we were only looking for real zeros, and we found it, just one of them.